All right. All right, welcome everyone. Sorry about the wait. Promise this is a tech conference. We had a few technical difficulties, but we'll get past that. So anyway, thank you so much for coming to reInvent and to our session on understanding total cost of ownership on AWS. My name is Mark Johnson. I'm part of our cloud economics team here at AWS, and I'm joined on stage with my colleague Rohit Rai, as well as Todd Curry from the Boston Consulting Group, who is one of our customers. So we're going to hear from him a little bit later in today's session. So quick show of hands, how many in the crowd have actually done a TCO comparative analysis of an on-prem workload or maybe a data center to AWS? Okay, quite a few of you. That's great. Good, okay. Some experts out there. So in today's session, we want you to come away with knowing a lot more about how to frame the business case for making the move to AWS, learn about some of the cost drivers about on-prem investments versus running workloads in AWS, how to do the actual comparisons themselves in a nuts and bolts way, and we'll talk through one of our tools with a demo. And then also, as I said, hear from the Boston Consulting Group about their move to AWS Redshift. So you might be asking yourselves, as you're thinking about moving to the cloud, how do I frame the business case? Where do I start? So maybe it's just a single application. Maybe it's an entire data center footprint, right? But where do I start? How do I make the business case to do this? What are the things I should be thinking through? Well, to start, we find that our customers are most successful when they think about their business goals. So you might be thinking about making a major shift in the way that you invest in IT. You might be thinking about primarily cost reduction. You might be thinking about improving performance or becoming much more flexible in how you provision your IT environment. But more than likely, it's a combination of these factors, right? So what are some of the starting considerations? So when you're building the business case, one of the first things to think about is thinking about your business demand. So think about how your internal and external demand for IT resources changes. How do you expect this to fluctuate in the long term? Can your existing infrastructure flex to meet the demand in a cost-effective way? You should be thinking about these questions as you're building your business case. Secondarily, think about capacity planning and utilization. So what is your current capacity? Do you know it? Are you provisioned for peaks? Are you over-provisioned currently? And finally, identify your operational challenges. So things like, is your data center going to run out of space, right? What about power? Do you have enough hardware deployed? Do you have too much deployed? Are you fully redundant? Are all these things the kinds of big headaches that you struggle with every day from an operational standpoint? These are the kinds of things you should be thinking about as you're building that business case, starting to frame it up with your organizations, selling management, on the idea of making the move. So these are the kinds of starting points to think about. So as you think about your long-term business goals, things like where you're going to invest in the next several years, how you're going to expand, maybe changing your business operating model, wouldn't a pay-as-you-go model that lowers your overall cost, where you don't have to guess capacity, wouldn't that be the kind of IT infrastructure you would want to be investing in to move your business forward and achieve some of the goals that you started out with? Also, as you develop and launch new products and services and expand globally, or maybe it's just across one region, wouldn't you want to have the agility and flexibility to do that while avoiding undifferentiated heavy lifting and not take forever to do it? These are the kinds of things you should be thinking about. So you have to think about both cost and value is the overall point here. So moving to AWS is really about both. So TCO is more focused on the nuts and bolts of the cost comparison, and value, thinking about ROI. What are the other benefits I'm getting? Some of the soft benefits. Sometimes when you're making this business case, both of those things have to be taken into consideration. So I'm going to shift a little bit to talk about one aspect of on-premises infrastructures that's often overlooked when your organizations are considering a move to the cloud. So there are studies that have come out by Gartner, McKinsey, and some others that have stated that the typical data center today is at best 50% utilized. That's at best. Those are some of the best run data centers out there, meaning that at least half the servers in a typical compute environment are sitting idle, doing nothing. I mean, think about that. That's a massive, massive amount of computing power doing nothing. So is this something that you guys are maybe struggling with? There are a lot of deliberate reasons why this happens. So I want to talk through some of those. And think about this in the context of your overall business case to move to AWS. So one of the primary reasons this happens is due to the way that applications are architected and the way that they behave. So here are some of the common demand profiles of application computing requirements. You might have workloads that are highly variable or what we call spiky workloads, things like web applications. You might be running workloads that are only on part of the time, right? And then you might have workloads that are cyclical in nature, so they have sort of peaks and valleys in their demand for compute resources. So in an on-premises environment, even one that's virtualized, you're essentially having to provision for peak, right? So do you really want to continue to buy and run infrastructures that have, that are provisioned for peak requirements only? Think about how much is sitting idle the rest of the time. But what else is going on here? What else is driving this gap? And this is one of the things that often doesn't get figured into the discussion about moving to the cloud. So think about the way you provision IT resources today. You probably have a lengthy spec and procurement process, even for virtual machines. You probably tend to buy things up front to avoid going back to the well again to go through the process of provisioning your resources. And you're also constrained by what you buy. So you can't trade in, you can't trade back servers. You're going to get pennies on the dollar for that, right? So you tend to go through this procurement process in a way that sub-optimizes the way that IT resources are built and run in your data center, in your colocation facility. And it's really, at this point, holding back a lot of the ambitions you have to move forward on some of those business goals. So when you bring workloads to AWS, you're making fundamental changes in the way that you buy IT services going forward. So we talked about that procurement process, right? Lengthy process you go through to do spec and provision and deploy. So with AWS, you're deploying in minutes, so we can knock that one off. Secondly, you're only paying for what you use, so a lot less idle capacity. Thirdly, you can trade in your instances. So within the same instance family, even if you bought RIs, you can trade in for a different instance type within that same instance family. Or if you're running on demand, you just shut it off and choose the right instance type and spin that up. Finally, trade backs. You can trade back even your reserved instances on the RI marketplace. So a lot of flexibility here. A lot of flexibility in how you provision IT resources when you move your workloads to AWS. Fundamental change here. And this, you have to think about all of this when you're building this business case. So what do you do with those savings? All that expensive resource that you put into investing in hardware, you can do things like investing in new projects, building new functions, new functionality for applications, investing in R&D, right? So moving all of the things that you were traditionally doing or spending on maintaining a hardware fleet, you can take that and bring more benefits to the business, things that they love. So I want to move this on, hand the torch here to my colleague Rohit Rai, who's going to talk about actually making the comparison between the two.
Thanks, Mark. So what we are, let's get down the volume. Yeah, let's get down the volume a bit. So what we are going to do in the next 20 minutes or so is go over some of these things which Mark talked about. So we'll look at why doing a TCO comparison is not easy. And the reason a TCO comparison is not easy is because creating a data center cost model is super difficult. Let me give you 4 or 5 reasons why we think so. The first thing is getting all the information to create an accurate data center cost model is not easy because it crosses through multiple organization silos. So for example, your power cost is often paid by facilities, not IT. So IT has no knowledge as to how much power bill is or power and cooling bill is. Even if suppose facilities tell you that this is the dollar amount we spend for power and cooling, it's very difficult to decompose that and break down into individual servers or racks. You cannot pinpoint exactly how much cost, power cost, cooling cost, goes for a particular server or even for a rack. It's not that easy. The other thing is the way IT cost is structured is very different between CapEx and OpEx. So your equipment, your data center infrastructure is all regarded as capital expense, capital expenditure, while your personnel cost, your power cost is all regarded as operational cost, OpEx. So when you marry CapEx and OpEx together, it adds to the complexity. How long do you amortize? Is it 5 years? Is it 15 years, right? So there's a lot of complexity around that. In some regions worldwide, taxes play a huge role. For example, I don't know anyone from Brazil here? Okay, somebody. In Brazil, taxes can be up to 25% of your data center setup. So when you are creating a TCO model, you have to consider the tax, and the tax even in the US varies by state to state, right? So that goes into your cost model. And then finally, your cost structure, depending on whether you are renting or you are privately own and operate a data center, is very different. So you compare a colocation versus owning your own private own operated data center is very different. So lack of information, lack of granular information, CapEx, OpEx differences, some things like taxes, and then the fact that whether you rent or buy makes a huge difference, makes creating a data center cost model super difficult, and that leads to this comparison being not that easy. But we'll try to go over this and show you a good model, at least the model we think about around that. So before we do that, one thing which we fundamentally believe is AWS has a lower cost structure than your on-premises infrastructure, whether that is physical or whether it's completely virtualized, maybe even 100% virtualized. There are a few data centers which are like that, but still. And why do we believe that fundamentally? There are 3 reasons why we believe that. AWS runs at a much higher scale. Yesterday, our VP James Hamilton did a presentation on AWS scale, and he talked about the fact that we have 28 availability zones throughout the world. So every availability zone is 1 or more data centers, at least 1 data center. And every single data center has close to 50,000 servers. 50,000 servers multiplied by 28, and each of the server is running X number of VMs, gives you millions of instances. So when you run at that particular scale, you get economies of scale. You have, supply chain procurement is highly automated. You have efficiencies around that. Your hardware is not sitting on the shelf, so you get a lot of cost benefit because of that. Mark briefly touched on this fact on thing around utilization. In the cloud, utilization is much higher than your on-premises, because what happens in cloud is that you are running millions of applications, and some applications have a very high utilization, some have a very low utilization, but they tend to cancel each other out. So when you do an aggregate utilization, it is much higher than what you can achieve on-prem, which is at best around 50%. Now another thing which AWS has done is this concept of a spot market. So what we do is at any given time, we take out all the extra capacity existing in our data centers and make that available in a separate market called spot market, where you as customers can buy instances at 1/10 of the cost, and we as AWS can drive our utilization higher. So it's benefit for you as customers and for us, in the sense that we can drive our utilization higher, and higher utilization means lower cost. So fundamentally, we believe utilization in AWS is much higher than you can achieve what you can achieve on premises. And then finally, we design a lot of our own gear. So servers, storage, networks. Again, James touched on this. One of the storage systems we have is more than 2 tons in weight and has 864 disks. You would not find that configuration anywhere in the world, because no one else designs like that. It's highly optimized for efficient operation. So what that means is when you design your own hardware, your servers, your storage, your networks, they consume less power, they consume less space, they are more efficient, and so they are less expensive. So fundamentally, scale, utilization, and our own custom hardware makes us believe that AWS has a lower cost structure than whatever is possible in an on-premises environment. So having said that, we touched a couple of slides back, we touched on the challenges around creating a data center cost model. So how do we think about solving that problem? The way we think about is shown on this particular slide. So this is a typical, the way we think about the methodology behind a data center cost model. And basically, there are 4 different layers or cost drivers we think about. So one is obviously your server, your compute, there is storage, there is network, and then there is personnel cost, your labor cost, right? Let me quickly go through each of them. So on the server side, it's not just only the hardware, it's also things like your spare capacity. If you are doing high availability, your spare servers, it's also maintenance. That's a big component. It's also the software. There is virtualization tax. There is operating system maintenance for that. So different items there. On the storage side, you have your disks, your SAN arrays, your fiber channel switches if you're using fiber channel, all that stuff. On the network side, you have routers, load balancers, switches, all sort of your network infrastructure. And then the big component which is shown in green there is all the personnel cost. In a data center, you would have a server admin, your virtualization admin, you will have a security admin, a network admin, storage admin, security personnel who will manage the data, maintain the physical security. So there's a lot of cost involved with that. And then finally, again, I touched on this a couple of slides back, is this whole concept of overhead cost, which IT, at times doesn't have sight into these costs, but all your equipment occupies space. So there has to be, that considered in your cost model. All your equipment needs power, they need to be cooled off. So at least fundamentally, those 3 big items need to be considered. Now, any model you create doesn't need to include all 4 of these, but it's a holistic model where, we look at all the layers. At least the methodology we advocate customers use. Now, another thing which I want to quickly touch on is when you look at AWS prices and you look at something like the price which we publicly publish, just don't compare that to any hardware vendor prices, and just don't compare a hardware to hardware pricing, because the price we publish actually includes a lot of other things. So for example, yesterday we announced Aurora, which is the new RDS engine. I think it starts at 29 cents an hour, something like that. Now that particular cost includes 6 copies. We manage 6 copies in 3 different data centers, right? So there is redundancy cost built in. We do the patching, so there is hardware maintenance and patching built in. There is, it occupies space, power, cooling, all that stuff, right? So the point which I'm trying to get across is just don't look at that number and compare against your on-premises hardware number, because that is not an apples to apples comparison, because there's a lot of things which go behind the public prices we publish. So with that, let me quickly show you a demo of the tool which we have publicly available. And this particular tool is going to show you the Okay, so this particular tool is publicly available, and the model we talked about, basically we took that model and we created this simple tool which you can use. So a couple of things before we get started on the tool. It's very simple to use. I'll show you within a couple of minutes, maybe even seconds, you can actually get a very good cost comparison. It's very comprehensive. So it touches on all the things which I talked about, your cost models, AWS, on-prem, and it's pretty credible. We work with hundreds of customers in refining this model. We work with Gartner, Forrester, a lot of analyst firms. They gave their validation. So you would see that, and it's really easy to use. So the first thing I do here is, this is the URL. The tool is present on the AWS website. So if you go to aws.amazon.com, you can see, but this is the individual, the actual URL. The first thing you see here is it asks you a couple of questions. Are you running on premises? Are you running in a colocation? So it's your own private data center versus renting data center space. You can pick any of the AWS regions, 11 regions we have. You can actually pick your physical servers or virtual machines, and you could do a lot of things on server, storage, network. Let's go through some of that here. So if I come here, first thing I can do very quickly is I can just input number of VMs, 2 CPU cores, 8 gig of RAM. I want to use Zen as the hypervisor. Just click here and click on calculate TCO. What this will do is I'm running on premises. I'm running in North Virginia. It's telling me at a glance, at a high level, that I can save 36% of my cost if I move to AWS, and this is over a 3-year period, right? And this is the dollar amount I would save. So this is interesting. If I come down here, what it does is it automatically picks the instance for me. So I don't know anything about AWS instances. I say 2 CPU cores, 8 gig of RAM. Give me the best instance which matches my configuration. And so it's giving me an M3 large, which is 2 cores and 7.5 gig of RAM, right? This gets more interesting. So let me come here and click on change input. And now what I want to do is let me just go here from a basic view to an advanced view, and a couple of other levers just open up here, right? So let me quickly add a couple of rows here, and I'll pick a random number of VM, let's say 50 VMs each. I will give a really random value. So 5 cores, 11 gig of RAM. This is really something which we don't have an instance for. I'll pick 7 cores. I would give 60 gig of RAM. I'll pick Zen for each of these. Linux is fine. I'll say they are running 100% of the time. And now what I can do is I can choose my optimization strategy. So I can say CPU here. I can say storage IO here. So what I'm doing here is basically AWS has 23 instance type, current generation instance type. In total, we have 37 instance type. Now, picking an instance is not an easy job because you don't know what instance is the right instance, right? Because it's 37 different instance types, families. So you don't really know. So what we have done here is we have given you this choice where you say that, look, my most important criteria is memory, and I want the lowest dollar per gigabyte of memory. I want the lowest dollar per gigabyte, so I can go with RAM. I need virtual cores more than anything else. So my optimization is CPU. And with storage IO, basically I need high level of IOs. I need large instance disks so I can perform these IO. So I can just choose these, and if I come back here, calculate TCO, what this will do is this will automatically pick up instances for me. So the first thing you saw is the number decreased from 36% to 29%, and you can see a chart here with the values. And if I come down here, now the interesting thing is I have no idea what AWS instances look like. And what this tool has done is it has made some recommendations. So it's saying M3 large is closely matching your first entry here. C3 extra large is matching this. I2 2 extra large is matching your storage IO requirements, right? So I have no idea about AWS instances, but it's giving me some recommendation. Now you might look at this and you might say, wow, this is where is performance? How do I know this is the right instance for me? So we cannot do that here, right? Because we don't know what your performance requirements are. But this is a very high level recommendation tool which is telling you what is the right instance type. At least it's solving that problem. And then you obviously have to fine tune and do other things to make sure that particular instance is the right instance. Let me make a couple of other changes. So other thing which I can do here is now let's say I would come here, I say these 100 VMs are dev and test VMs. I'm not running them 100% of the time. I'm only going to run them 10% of the time. My utilization is let's close to 10%. These ones, my utilization is close to 40%. And the storage IO, maybe it's running a database, running all the time, 100% of the time. So now when I click on this calculate TCO, what it does is the numbers change, and if you come down, basically it's telling me that the first one, M3 large, is running on demand. The second one is running as a medium utilization RI, and the third one is running as a heavy utilization RI. So on demand, pay as you go, stop using, stop paying. Reserved instances, you pay a low upfront fees, get up to 60% in discount, right? So it does that automatically. You don't have to go through and change your Excel files and look at the latest cost, whatnot, right? And it has a couple of nice charts here. it's telling me, my majority of my cost is reserved instance. There is little bit of medium RI, this is all heavy, and this is a little bit of on demand here. So it's giving me, sort of this cost breakdown. I'll show you some detailed calculation also, but let me quickly make a couple of other changes. So I click on change inputs, and now I say, look, this is all looks good. This is all on premises. What if I put this in a rental facility? What if I go to a co-location? Because look, I don't want to run this all on myself, right, in my own premises. So click on co-location and click on calculate TCO again. And what it will do is, as you would see, the numbers went down from 41% to 31%, right? And all the instances remained the same. It's on demand, medium, heavy, reserved instances. And as you come down here, there is a lot of details which you can see. So the first thing you see here is it's telling me on the left hand side, what does my cost look like in a co-location facility, right? So it's telling me, these are my physical host, this is the VM density I get, and it's giving me a lot of other cost items. How many racks I have, what is my power cost, what is, my, virtualization cost, all that stuff, right? Typically what we have seen is, as you see here, this is only 4 racks. Typically the break-even point we see is around 5 racks. So if you're running more than 5 racks, your own premises data center becomes more cost effective. Anything less than 4, and less than 5, a co-location facility actually is cheaper, right? So you could do all that. Let me quickly come here, and this is all good. This is all running in the US. What if I take all this and run this in our newest region, which we just opened last month in Frankfurt? If I just do this, right? If I just change it to Frankfurt, how will things change? And if now I see my numbers decrease substantially from 31%, 41% to 16%, right? And the reason it is happening is AWS cost has changed, your colocation cost has changed. And this goes back to the point I was making earlier. Taxes are different in different regions. Your hardware prices are different, your storage prices are different, all that is different, right? So that is all accounted in the cost model here. So it changes, right? So you can pick any region you want. Let me go back and make a couple of other changes here. So let's say I want to include storage, 100 terabyte, 10,000 IOPS, my backup is 10% every month. I have a network which I'm using, gigabyte per second network, peak to average ratio, I have something. These are my IT admin, this is the salary, this is sort of what they manage. So now what I quickly did is, without spending a lot of time, maybe few seconds, I was able to input all these values, and now I can see a complete picture. I can see my network cost, my storage cost, my server cost, all that, labor cost and all that, right? And if I come down here, now I see more details on my storage, my network, my server, all that. And if I click on calculations, I can actually see even more. I can see my server costs. I can, so left hand side is all on premises, right hand side is all AWS. I can see my storage cost. I can see my network cost, my labor cost, all that, right? So it's pretty comprehensive. It's has all the details if you want to go over all these details. Now I just want to show one last thing is, you look at all this, right, and you say this is all great, but I want to change some of these assumptions because I really don't believe your numbers, or I have some better numbers. So let's say I want to change my server price, I want to change my network overhead, I want to change the power cost I pay, I want to change my colocation rental which I pay. I want to change all these numbers, right? So you can modify all these assumptions, click on save and recalculate, and now as you would see, the numbers would change. So with a tool like this, where would you use a tool like this? The place where you would use a tool like this is, suppose you are running on AWS or you're planning to run on AWS, and you want to quickly grasp what will be my cost on premises versus running in the cloud. You could use a tool like this and just quickly within minutes get a result. And you can save this. You can send it to other people, and you can discuss some of these numbers. Okay, So just to wrap up, so everything you saw was all hard cost, right? So we looked at the server cost, storage cost, all that stuff, right? The thing which we really didn't touch on is the value component. As Mark briefly touched on this, with AWS, let's say on the hardware side, all the upgrades happen automatically. So today morning we announced C4 instances which have Haswell processors. Now if you're running your own on-premises infrastructure, how easy it is to change the processor on the fly. It's not easy, right? You have to open a PO, you have to go through procurement. It's a lot of hassles. In AWS, just stop using your current instance C3 or C1 and just migrate to C4. So all this infrastructure upgrade happens automatically. You wake up the next morning, all this is done for you. Similarly, every database, you would need some kind of replication. If you want to do replication yourself, look at the number of steps you have to manually perform to create any kind of replicated database. On the AWS side, just click on this particular button, one button, and you get this multi-AZ deployment, which is a synchronous replication between two data centers with sub-millisecond latency, all done for you. You don't really have to do anything, just click a button, this gets done. And so there's, another example is autoscaling. If you don't need instances running all the time, you can switch off servers here, and you are not paying any money. You're just paying money for the portion you are using your server. So the point is, there's a lot of value, and you can attach a dollar value, a dollar number to the value piece, which we don't do in our models right now, today, something we are planning to do, but it's nonetheless, it's an important fact which you should keep in mind when you are calculating total cost of ownership. So with that, I'll invite Todd to come and talk about his particular use case with AWS.
Thank you, Rohit. So I'm Todd Curry. Oops. Thank you. I'm Todd Curry. I'm a big data expert at the Boston Consulting Group. And BCG, Boston Consulting Group, is a strategy consulting firm with about 10,000 employees around the globe in 80 different offices. We generally do deep analysis of problems for Fortune 1000 customers. And the tools that Rohit just described have been incredibly valuable for us as we consider where in the world we want to put our architecture. But I'm actually going to take a step back and describe a few things that we went through to sort of help explain the journey on a different kind of stack, an analytical stack. So every year we do about 1,000 projects that are deeply analytical. The data sets can range from something very small that can be handled in Excel to hundreds of billions of rows. When Mark mentioned demand, capacity, and organizational challenge, we know roughly what our demand will look like, but we have no idea what shape the data will come in. So for capacity planning, it's very difficult. And what we've done in the past is build, use virtualized servers and throw up Microsoft SQL Server instances for various case teams as they've had data come in. When we do that, SQL Server is a great product, but we are setting up on a very thin slice of hardware, and we don't have the time, frankly, to be able to tune that to the peculiarities of the data that we are bringing in. Many times, because we're seeing the data for the first time ourselves, we don't know necessarily what our process is going to be as we go through it. So we're under huge time constraints. We're waiting for data, typically waiting for data, and the client's waiting for us to do things with data. So it's always an uncomfortable dance. Then generally, if the data were easy and clean, our clients would have done great things with them already. We typically have to do a lot of cleanup, so our ETL processes have to be very quick. We need data throughput. And in this environment, once we've cleaned it and loaded it, in this environment that I described, we typically were seeing things like 15 to 20 big queries answered per week. And so that for us is an important metric. We'll talk about it in just a second, but as you have a project team of 5 to 20 people all gathering around a big store of data, there are a lot of questions. And if the fundamental technology doesn't have the kind of data throughput we need, then we are impaired. Last, what hampered us, I think, and sort of was eased as we made our shift to Redshift was really cost, familiarity, and security. So we sort of feel like we had to take a leap 2 years ago with Redshift, move into a Linux world. We were very much a Windows shop, Microsoft shop. Security was a concern. We felt very good about AES 256 on Redshift. And it worked for us. So we went from 15 queries a week to 25,000. It was watershed for us. Literally, teams could deploy Redshift with minor tuning. You're tuning at the table level, and it's not that hard. Our DBAs were more than able to make the shift. Security, as we talked about, was largely solved, and overall cost went down tremendously. And so we started looking at this really in cost per query. As you look, we started off with something on the order of $30 to $50 per query when we took our internal server costs that were allocated to us, we divided it by these queries that we were running. When we dropped down to Redshift, it went to a nickel, okay? So for us, that was with one project team on a 2 8XL cluster, which is like a Lamborghini for analytics. It's fantastic. We dropped so that team was not impaired in any way, getting phenomenal throughput. And for us, the future is likely to be a move to multi-tenancy on that Redshift cluster. We've learned now through several pilots that we can have different project teams are typically not banging on the same hardware at the same rates at the same time. So we actually, from an analytics standpoint, can have multi-tenancy and drop this down even further. A couple of things just to give perspective. I know this is part to arm you and sort of help your analytics colleagues make the case for better hardware as they move forward. I know many of you are developers, and perhaps a few are on the finance side. Analytics is typically something that sort of comes into the cloud through the side door. Analytics teams are looking for faster performance. They've got old hardware in some cases, and we find that once data are there, the plumbing typically runs one way. It stays. And on the development side, what you've seen from the TCO perspective, and certainly as you think about going all in with the cloud, a lot of these TCO tools can help you tremendously. For us, and as we talk to clients who are thinking about moving their analytics in, this cost per query metric, at least, has been watershed for us, and is something that we talk about with clients. So with that, I'll hand it back to Mark to wrap up.
Thanks, Todd. Compelling use case there, moving to Redshift. So I just wanted to close by saying that we have a lot of resources online. If you have questions about how to do a TCO comparison, we have what we call our economic center on the AWS website that talks about customers who have saved money on AWS. Obviously, the tool that Rohit demoed today is also available to you, and we're planning on actually making more enhancements to that in the future, but that's currently online. And lastly, my team is available to engage with you one-on-one for your specific situation. So if you're considering moving to the cloud, and TCO and ROI is one of the big considerations when you're making this, when you're doing the comparison, trying to make the business case to move, we're available to work with you one-on-one to build up the cost model that can help you through that transition. Because a lot of times that's table stakes of making the move, right? So cost is one of the big pieces. So we're here to help you with that. And secondarily, as I mentioned, our team also helps existing customers who need to optimize their costs on AWS. So maybe you just moved and you need to fine tune. We're also available to do that. So anyway, thank you again for attending our session today. Encourage you to give us 5 stars in our evaluation here, even with the technical difficulties we had. But thank you again for coming here. It was a pleasure.